Hey guys, this is Carrie, and in this video we're going to be doing homework number 7. So let's get started with the answer key. It says write each of the following as fractional exponents. So the most important thing to remember about a fractional exponent is that the number on top is going to be the power and the number on bottom is going to be the root. So in this case we have we have a root of 3, so that goes on the bottom, and a power of 5, so that goes on the top. I think you guys are good with B. Now the one secret to remember with C is when you have a square root, you usually don't write the 2, but there's an implied 2 here because square roots cancel squares. So in this case it would be x to the power over root, and even though the 2 wasn't written there, because of the square root, the root is the second root. So you guys are going to do that one. Alright, now for 2 I meant to actually put this question after 3, so I'm going to come back to it, but it doesn't really affect us that it's a little bit out of order. So with this one, write each of the following as radicals and powers. So x to the 2/5, there are 2 ways to write this. You could write the 5th root of x squared, or you can switch the order so you have the 5th root of x squared. Either one of those is correct, as long as you remember that the power is in the numerator, and then the root is in the denominator. Alright, so then for the next one, we'll have the x to the 5th power with the second root. But when you have the second root, you don't have to write the square root there, this 2 there, because square root is automatically the second root. Or if you wanted to switch the order here, you could have the square root first, and then the 5th power. Finally, for C, you've got 3x to the 4/3, and this one is a little bit trickier. So you have either 3x to the 4th, all being third rooted, or you've got 3x being third rooted, all to the 4th. Now, when you write it this way, I actually prefer it this time, because you can actually simplify things a little bit. 3x to the 4th is 3x times 3x times 3x times 3x. And all of those 3's actually give us 81 x to the 4th. Because 3 times 3 is 9, 81, and then x times x times x times x is the x to the 4th. This could actually be simplified further to simplest radical form by breaking down the 81 and breaking down the 4, but I'm going to avoid that just for clarity at this point in the video. Draw a rough sketch of each of the following functions on the corresponding axes. Make sure to clearly indicate tick marks. So a lot of us forget to do that when we draw a rough sketch, but we should be adding tick marks. So for this one, what I'm going to do is I'm going to start off with the basic cubic graph. But because this one has an inside transformation of -3, I know it's going to be the opposite, so we'll move 3 to the right. And then this one has an outside transformation of -4, so we're going to move 4 down. So the tick marks have to be included here. And then what happens is that vertex point, that vertex point, I'm going to try to draw it here. That vertex point, let's see if it'll let me do this. Yeah, that vertex point has to move from 0, 0. Oh, I got one of the tick marks. Oh no, down the 4, and then 3 to the right. And so that's where this should go with the vertex at that point. All right, cool. Now I'm going to let you guys do A on your own. For 5, this one's very similar to one of the ones we saw in class. Let's solve it by hand. So first step, we got to use some inverse operations to isolate x here. So let's square both sides. Squaring both sides gets rid of the square and gives us x squared plus 3 equals negative 2x all squared. X squared plus 3 equals negative 2x times negative 2x is 4x squared. Minus x squared on both sides gives us 3 equals 3x squared. We divide by 3 on both sides. We get x squared is equal to 1. We take the square root of both sides. But because we start with a power of 2 here, we're expecting 2 answers. So we get x equals positive 1 or x equals negative 1. Now with square root equations, ones that start off with square roots like the one we have here, we actually have to check both answers exactly. So you get the square root of 1 squared plus 3. Is that equal to negative 2 times 1? So usually we think of this as a check, but this is a mandatory step when you're solving a square root problem. 1 squared is 1. We get negative 2. We get the square root of 4 is negative 2. And this is not true. 2 and negative 2 are not the same thing. So we have to reject the solution. It's called an extraneous solution. So guys, I'm going to leave the rest for you. You do have to check this one too, okay? So make sure you check it and see if that solution works, because it's possible that they're both extraneous. Write the following square roots in simplest radical form. All right, now this is designed to be a pretty quick problem set here, so just remind us of the rules that we use to simplify these things. So x to the 12th being square rooted. Because square roots cancel squares, we're wondering how many x squareds does x to the 12th give us? So if you think about that, that's really 6x squareds, because that would be 6 times 2 for 12 total x's. So we get x to the 6th. For this, we're trying to make not groups of 2, but groups of 4. So how many groups of 4 can we make? We make 3, so we end up with 3 groups of 4. And because this is a fourth root, that fourth root cancels with all of them, giving us just x cubed. For problem C here, we're wondering how many groups of 5 we can make. So it looks like we can make 2 full groups, because 5 times 2 is 10, but then we have 3 leftovers. So we get x squared, and then those leftover ones stay inside of the fifth root. Now what's important here is make sure you include the 5 from the fifth root. It does not change to a different root. Cube root of x to the 32nd. For that one, what we have to do is we have to divide it by 3, so we make 32 over 3. That's 10 full groups plus 2 extras. So we get x to the 10th, and then inside the cube root, we still have x squared. And I'm leaving an extra space there just to show, they're outside, but you don't have to leave a space quite that big, actually. For this one, cube root of x to the 999th, I'll leave that to you, and a calculator might be helpful for the F1, so I'll let you figure that one out. Now these two are actually pretty similar, but I guess because this is the review for the quiz, I will go over both of them, although I don't think I need to. Cube root of a negative means that the final answer will be negative. Next up, let's break down the 243. 243 breaks down to 3 and 81. 81 breaks down into 9 times 9, 3 times 3, 3 times 3. Now the benefit of having it like this is we're looking for groups of 3. So I see one group of 3 here and a couple of extra 3s. So let me write that as 3 cubed from this group, and then those 2 extra 3s right here. Now we still have x to the 12th, this is multiplication sign, y to the 44th. So let's finish this one up. Cube root and cube cancel, giving us 3 outside. X to the 12th, when we cube root it, we can make 4 full groups with no extras. Y to the 44th, when we cube root it, this one's a little tricky. 3 times, if we do 44 divided by 3, let's see what we get. I think we get, let's see, 12 would be 36, 13 would be 39, 14 would be 42. I think we get 14 full groups, and you could use your calculator for that. So we'll have 2 extras. So we get y to the 14th, and then inside of our cube root, we get 9, sorry, that's multiplication line 9. No leftover x's that perfectly divided, but we do have a leftover y squared from our 2 extras. Cool. Put the following in simplest radical form. So for this one, I'm going to start you off, but then you'll have to finish on your own, I guess. I'm not going to go over this one completely. The 1/4 power means the 4th root of this whole thing to the first. But when you have something to the first power, that just means you have that once. So it's equivalent to this. All right, guys, so from here, you're going to solve a problem similar to the one we solved in 7, but a little bit easier. So let me get rid of that box so you don't think we're done. And, ooh, wow, getting rid of too much, getting rid of that box so we don't think we're done. And then I'll leave it for you here, and I'll show you that the final answer hasn't been included yet. Hope you guys found this helpful and that you're ready for your quiz on Thursday. See you then.